Hi everyone, this is a short video about reviewing how we solve inequalities. So suppose we are given the equation or the inequality 3x plus 2 is greater than or equal to 6. So we solve inequalities the same way that we solve equations. We need to get variables on one side, constants on the other. So in this situation, right, we would subtract 2 so that we could get 3x alone on one side of the equation. And so we'd get 3x is greater than or equal to 4. And then just as we've done in the past, right, if I want to get x by itself, I need to divide by 3. And so dividing by 3, we get x is greater than or equal to 4/3. What this is saying, right, is that the values for x that are greater than 4/3 or equal to 4/3, if plugged into the original equation, should give us something that's true. If I want to graph this on a number line, it would look something like this. So we draw a straight line like this. I indicate where 0 is. I indicate where 4/3 could be. It's a little bit bigger than 1, right? Because we're saying it's greater than or equal to, we put a closed circle over the 4/3, and we draw an arrow going off to the right. This indicates that all of these numbers over here on this part of the number line that is greater than 4/3 are potential solutions to this problem. So if we pick a number that's greater than 4/3, suppose we say we choose, let's say, x equals 2, and we plug in x equals 2 into the original equation. 3 times 2 plus 2 is greater than or equal to 6. 3 times 2 is 6, plus 2 is greater than 6. 8 is greater than 6. This is true, right? So that means that, any solution, any number that we choose on this side of the number line is going to be true for this situation, for this equation. So one of the things that we also talked about is what happens when we deal with dividing or multiplying by negative numbers. This is the multiplication property of inequalities. So if we multiply or divide by a negative number, we must flip or switch the inequality symbol. Right? This is the multiplication property of inequalities. So suppose I'm given a problem like negative 3x is greater than 9. The way that we would solve this, right, is that we would divide by negative 3. Because we divided by a negative number to solve this, we got to change the inequality. So on a number line, right, the solutions would look like this. Here's 0, here's negative 3. We would have an open circle, and then we would draw the arrow going off to the left because we want numbers that are less than negative 3. Now to prove that this is true, we need to pick numbers that are less than negative 3, or we could, right? So suppose we pick negative 7. So we're going to say, let's say, try x equals negative 7. So let's plug it into the original equation. Negative 3 times negative 7 should be greater than 9. 21 is greater than 9, which is true. All right, so whenever we divide or we multiply by a negative number, we have to change or flip the inequality symbol, right? So we have to flip. All right. But in terms of solving inequalities, it's exactly the same process as we use for solving equations. Even if we're dealing with fractions, you know, in this situation, right, if this was an equation, we might try to find a common denominator. Common denominator here would be 12. So, you know, we would make these changes. We would multiply by 4, you know, multiply by 6, multiply by 3, multiply by 4, right? So we get 8x plus 6 greater than or equal to 9x minus 8. You know, and all of these are over 12. So, you know, so if I did this over 12, over 12, over 12, over 12, now I can just get rid of the 12s, right? I can just erase them or get rid of them. And I can solve this equation without dealing with any fractions, and it would be solved exactly the same way. Suppose, right, we decide, maybe I'll use a different color here, we just subtract 8, negative 8x, subtract 8x from both sides, we get 6 is less than, greater than or equal to x minus 8, and then we add 8 to both sides, we get 14 is greater than or equal to x. And one of the things we talked about in class was that it's possible to take an inequality written in this way, and we can rewrite it. We don't have to write it in this particular order. We can take and flip everything around, but that also means we need to flip the inequality symbol too, right? So this expression here and this expression here represent the exact same solution set, and the solution set would look something like this. Here's 0, here's 14 up here. We would have a closed circle. And we would draw the arrow going off to the left. So we want all values that are less than or equal to 14. Now, we also talked about in class today, we talked about compound inequalities. So here's an example of a compound inequality. Here's an example of that. We can solve this in two ways. We can either do two equations, for example, two inequalities. Like we can either solve this inequality, which is this first half here, right? That part. And then we can also solve 2x plus 4 is less than 9, which is this part of the inequality, this compound inequality. So there are two parts, right? So we can solve each one of these separately. The other way that we can deal with this is we can simply solve the compound inequality as one single problem. So for example, if we did this, the goal is to get x by itself, right? This is what we want to solve for. So we subtract 4 from every part of the problem. Negative 7 is less than or equal to 2x, which is less than 5. From here, then we would divide by 2. We get negative 7 halves is less than or equal to x, which is less than 5 halves. And that would be our solution to this problem. Now, this is our solution set, right? So likewise, you know, here we can do very similar things we can solve for x here and solve for x here. In the end, it's going to give us the same answer here. For example, if I subtract 4 and subtract 4 here, we get 2x is less than 5. If I divide by 2 and divide by 2, we get x is less than 5/2. And this is this part of the solution right here. If we, subtract 4 here, we get -7 is less than or equal to 2x, and then we divide by 2, we get -7/2 is less than or equal to x. And this solution is this part right here, right? So it all combines, and it looks really messy now, right? But it all combines to make this one solution. So however you decide to approach the problem, either by doing it as two individual problems or doing it as a single problem, you will end up with the same answer in the end. Let me just I'll do another one just to show solving it at least as a single problem. 2 minus 2x plus 6 is less than or equal to -4. So subtract 6 from each part of the problem. -16 is less than or equal to 2x, which is less than or equal to -10. And then from here we would divide by 2. We get -8 is less than or equal to x, which is less than or equal to -5. In terms of graphing the solution set, here's 0, here's -5, here's -8 farther down the line. Since these are both equal to's, we're going to put a closed circle over -8 and a closed circle over -5, and then we're going to connect the dots. And that means that all of our solutions are between -8 and -5. Okay, so one last example. 3/2 is less than or equal to 2/3 x plus 6 less than or equal to 9/2. And we can treat this just like we treat any other problem where we might want to get rid of a denominator. In this situation, right, the common denominator for 2 and 3 would be 6. So we multiply top and bottom by 3, top and bottom by 2. Here, top and bottom by 6. And here, top and bottom by 3. So we would get 9/6 less than or equal to 4/6x plus 36/6 is less than or equal to 27/6. And then we would just get rid of the denominators. Okay? We just get rid of the denominators. And then we would solve this problem just as we would solve any other problem. We would, for example, we would subtract 36 from each part of the problem. And being careful of our arithmetic here, and then we would divide everything by 4. So we get -27/4 is less than or equal to x, which is less than or equal to -9/4, right? Or, -6.25 is less than or equal to x, which is less than or equal to 2.25. So you can change this to decimals as well. And then you would, in terms of graphing, here's 0, here's -9/4, here's -27/4, closed circles over both of them, and then you would connect the dots. Okay? So this process that we use for solving equations works exactly the same when it comes to solving inequalities. So that's the quick, fairly short review of working with inequalities.